Hello and welcome to the Earth Science Associates video on the golden set of LAS curves. This is a part of the GOMcube Analytics add-on, and we primarily use this in our well log viewer accessible through GOMsmart. So if you'd like to actually take a look at a video on that and how to use the well log viewer and what kind of functionality it has, check out the link in the description below. This video is going to focus on the golden set itself and mostly on how we created this data. The golden set is a table of well log values of the most important curves. It is grouped by well and only uses the best available data. So what this means is that for any well, you can easily see all the data available and be confident it's the best data. To start off with, we analyzed over 45,000 LAS files. These are the digital logs released by the government after their necessary hold period. The well logs, the very first step was to classify them into a standardized set of names. So, for instance, with gamma ray, the standard mnemonic is usually just GR. However, different companies use many different mnemonics for gamma ray, and so you'll see GR1, GRA, and a whole bunch of different things like that. And so what we did, we started off with a database of mnemonics to curves, and that gave us a lot of classification right there. However, looking through them, we found that we were missing a lot of different curve names. Very different special mnemonics that don't show up very often at all. And so we did a lot of searching through the description of the curves and things like that, looking at the units, and that way we were able to classify a lot more of the curve names into a nice standardized set. Frequently what would happen would be we would have multiple LAS files for a single well, so we had to combine the data from these multiple LAS files. So for the most part, you would have one LAS file that had mostly G&G data like gamma ray, resistivity, sonic, and you'd have another LAS file with maybe mechanical data, so rate of penetration, RPM. And then we could just combine that very easily. In some cases, though, you would have, say, gamma ray repeated in multiple LAS files. Now, in that case, we did not do any stitching of the data, so we would never combine two different gamma ray values from different logs because we were worried about making sure that things were standardized and things like that. We didn't want to worry about that. And so we had to make a decision on which gamma ray file to use. And so in the most part, we just picked the one with the most data. However, we also weighted this by depth. And so we picked the one with the most data deepest in the well. The only other special case would be resistivity. And if you had, we always pick deep resistivity, but if you had two different LAS files with resistivity, sometimes one was deeper than the other, we would default to the one with the deepest of resistivities. Combining all this with our classifications, we make nice, very clean tables of well log data by API number. This is utilized in our GOMcube Analytics add-on to plot the well log data in a browser, so you don't need any additional software or anything like that, and you can see that on the right. And then we also have actually made this displayable in the 3D GIS. This is a very novel display, not something you usually see, and you can see that on our picture on the left. In this example, the pink color would be the lower gamma ray values, and the green and very dark green would be the higher gamma ray values. To give you an idea of the numbers we're dealing with, we'll go over that now. So, like I said in the beginning, in total we had over 45,000 LAS files. Now note that is as of making this video. This is September 2021. So if you check this out later, we should have more than that. Because this is something that we're continuously updating, and as new well logs are released, we run this again and we get more and more data. Now, of those 45,000, you get down to only about 30,000 that are actually usable. And the biggest chunk that we miss here is because a lot of the LAS files are actually in time only and not in depth. So these become not very useful to us because we're trying to actually make plots in depth, and so we can't use those at all. Now, the good news is that almost always when there's a time LAS file, there's also an associated depth file, so you don't actually lose too much real data there. There are some LAS files, though, where the number of curve names is mismatched with the number of actual columns of data, and so you can't figure out which column is which curve and things like that. And so there are some just data problems that we have to throw those out as well. Now, we are only looking at a particular subset of data, which we call our golden set, our golden data. And so not all the LAS files have those curves. And so we lose some data that way, and we end up with about 25,000. Now, of these 25,000, we can distill them down to about 5,000 unique wells. And so you can see actually on average there's 5 LAS files per well. That's only on average. In general, there's some with only 1 and then some with up to 10. So we'll end up with 5,000 unique wells. To look at some of the numbers in particular of the exact curves that we're using, we classify them into general categories here. So this would be our G&G categories. And you can see that with gamma ray and resistivity, we almost always have those values for all the wells that we have data on. And then neutron and bulk density of a very big chunk there, and then less for caliper and sonic and lithology. The lithology would be the percentage of sand, shale, salt that we go through. In our mud logs, you can see that we have in general a lot less data. But when we have mud data, the main gases C1, C2, C3, we usually have those. The C4 isonormal, C5 isonormal, a lot less. And then some total gas and then mud temp in and out. Finally, for our mechanical data, you can see that for the rate of penetration, we almost always have that. And then for the rest, we don't have as much, but still a good chunk of RPM, weight on bit, torque, ECD, flow rate, and pump pressure. So this concludes the overview of the golden set of data. Again, if you'd actually like to see the well log viewer in action and how to access it and all its functionality, check out the link in the description. Thank you for watching.